I'll be showing you rapid texturing, one of the artistic functions of design with Easystone. I start by going to the Draw tab and find the Components button, and then to Artistic. Wall panel, and then I have some options on different types of wall panels to create. And the one that I'm focusing on right now is the rapid texturing. Here I'm given a series of variables, essentially, to enter or change. And then I'll produce a result on the right-hand preview window. I can drag my preview window open a little bit more and maybe even open these. So the layer, if you choose to change it, you can. I don't know that that matters, but the next option is to create waves vertical or horizontal. And I think the idea is to give the waves some vertical dimension. So I need to put a check mark in the wave in Z box and then OK. And I found if you forget to press OK, it's not going to accept the value. So just be sure to make the change, press OK, and then you can verify that the value has changed up above. Additionally, with each variable, we have a brief description of what is happening. So the next option is random. You can choose whether you would like a random pattern or not so random pattern. And then OK. I should say random or consistent. You'll either have a repeating pattern or maybe more of a random pattern. The length is the length of the panel that you wish to produce. This may seem small, but right now I am working in inches. This also works in millimeters. But for my example, I'm going to stay with inches. I'm going to go 24 inches for a panel length. And then my width, I will be 12 inches wide. So 1 foot by 2 foot. And then my frequency. Frequency is the distance in x, a wave of two maximal points. So the visual really helps clarify, in my opinion, what DDX is trying to describe here. So the maximum distance between waves. So I like to open this up a little bit. Right now it's at 4. How about I double that to 8? Let's see what we get for a result anyway. The maximum amplitude, again, I'm going to take a look from the top, and you can see a little better that we are describing what is our y direction deviation, the maximum distance that I'm willing to let the software go. 1.8, maybe I want to tighten this up a little bit. 1.18, not too much, I guess. 1 inch I will go with. And the minimum, what is the minimum distance that I would like to allow between amplitudes? And 0. How about a quarter of an inch, 0.25. The angle, a rotation angle around the x of each wave. For this example, I'll leave it at 0, but once you get this in your hands, feel free to adjust that and see how it works. Offset distance in y between waves. So what's the distance that I want to maintain between wavelengths? That's about 1 inch. I think I'm going to open that up a little bit more. On a 12-inch panel, I will go 1.5 inches and check my result. Offset phase. Phase displacement in x. So do I want to have an offset from wavelength to wavelength? You'll see the result with this. I like that effect. It gives it a little bit more of a random movement in the panel. I had a 1.5 inch offset on y. I will go about half of that in x. That says it's expressed as a degree. I'll change my mind and bring this back to 0. Repetition is the number of waves that will look alike before a new repetition is made. I have a short panel width in the Y direction, being that it's only 12 inches. So my repetitions, I'm going to make a set of 3. Frequency and Y of the lateral waves, further modulation. I think I was confusing this with the offset in degree. I'm understanding this as the adjustment in wave forward, but I believe that might actually be here, frequency and Y of the lateral waves. I don't know. This is definitely a linear measurement. On a 24-inch panel, let's open that up. Let's say I were to make it 3, I should have 8 waves in 24 inches. Or 6, I would have 4 waves in 24 inches. Accept it. Amplitude in Y of the lateral waves, further modulation. I'm going to leave it at 0. And again, feel free to change my mind. I'm going to make it 2. And then let's see what kind of a result we get. Offset. Where was my offset? Let's see what I have. Preview time. So because my waves are in Z, I won't be able to see them from a top view down. I need to look at them from the front. And it almost looks like maybe my waves are... Okay, let's see how we can adjust that. I'd like to keep them all down starting along the plane and not moving up and down. So amplitude, would that be... Let's measure that. That vertical distance is 0.92. No, how about 0.92? You're coming down and you're going up. That's better. Okay, so it's doing what I thought it was going to do. It's how much adjustment are we having across here? And I want everything to stay essentially averaged out planar on the ends. So if I look at this from the left, my waves are starting on average at the black line. I need that. Looking at it from the front, how deep are we going? So my deepest point, I would suppose, is probably about this wave to my maximum point, which looks to be about here. I can say near point. And my Z height is 0.8 inches, so we're looking at 0.79. I think that's about 20 millimeters, 21 millimeters maybe. So notice with random pattern, I'm getting wavelengths that are very steep, some that are kind of shallow. They're alternating, so to speak. Let's try to turn random off. I'm going to say OK, and then preview it. And now I have a much more consistent waved panel throughout. If this is your desired effect, so be it. But just know what possibilities you could get with random or not random. I think to keep close to the design that you are having, random is probably what you would like. And maybe we just need to tighten up some of our minimum and maximum. So maybe the maximum amplitude is only going to be 3/4 of an inch. And then preview it. So you can see how our panel has changed. I'll take a look from the front again. So let's kind of tighten things up a little bit. All right. Now and just continue to modify the variables until you get a panel that you think is acceptable. After that, again, you'll preview it, and then you will insert it. Now that the panel has been inserted, I can choose close. Close the window. Close. And I have my primary structure to create surfaces. Now to create a surface, I go to the Build tab. I would go with Loft in this case. And just pick from one end or the other, but once you start in a direction, maintain it. I'm going to pick my first path and just continue to go through here one by one until a lofted surface is created. Now it's important to note that lofting a surface can start to consume processing power. This is a mathematically generated surface. So the more complex of a surface you have, the more time this is going to take. So as long as you're seeing the preview generate, it's okay to click on to the next path. Once I have all my paths selected, I say OK. It's asking me how do I want to synchronize my surface. Right now I'm synchronizing by length, so it's synchronizing the surface from the right end to the left end because all my paths are the same length. I can synchronize along extreme points, which I think in this case isn't going to make any changes, or I can synchronize across customized paths, which would be like a cross section that you draw between here, but I haven't made that. So I think the correct one in this particular instance is either lengths or extreme points, and then I say OK. And now when I select on my surface, this is what you will machine. I'm going to save my project. And then I'll go to machining. Once in machining, I need to give some depth. My thickness is only as thick as my part is currently. So maybe I have 2-inch material or even 3 cm. And it's looking at the highest point and dropping the rest of my Z down. So it knows that it's only going to work the top. If, for instance, maybe I want to work a little bit off of the top, maybe I am at 1.2 thickness, and then I'll offset a little bit, 0.02. So now I have a little bit of material above. You can say OK. I choose the surface that I want to work. Let's see what I have for roughing operations. Blade normal. I might not even need roughing, to be honest, because there isn't a whole lot of depth here. Maybe I can just take a what I would call like a semi-finish. So let's go into finishing. It says blade transversal, but we'll do blade transversal next. So what I would like to do is just blade normal, and I'm going to step over the thickness of the saw blade just to get, like I said, a semi-finishing. And then with this blade, I want to have a little bit of over material on the surfaces. Just under an eighth, or yeah, just under an eighth of an inch, so 0.1 inches. And apply. Say OK. And then I can do, it's such a small part, this blade looks just gigantic over the top of that surface. Another operation, but in this case I do want to go transversal. So normal, transversal to have a sweeping finish. But depending on the diameter of your blade, and this is something that you'll need to experiment with, we're going to increase the step of the blade. Length exit definitely doesn't need to be that far. Do rise in Z, we're going to say no. And let's try it. I think considering the way the wavelengths are, I do not want to be going transversal across my surface in this fashion. I want to turn my blade 90 degrees. So let's say 90. And I'm still coming out, but over material I want to get rid of for this operation. So I have this drop down on the edge of the surface. I do not want that, and I'm pretty sure it's because of this. So I can either make it 0 or just keep coming down with it. There, that'll do it. That'll keep that saw blade on that surface. I chose a contour, went by a surface contour, and now we're contained inside. Let's say OK. I'm going to save my project here, and let's see what one looks like. Maybe not the most perfect rendering, but now you can kind of see what your panel will look like. So that's rapid texturing in a nutshell. One more addition. I wanted to see the simulation, so I put it on a test machine. This is not your machine, but a DDX generic machine. We'll see what it looks like. So this is the semi-finishing. It's running through there. You can see the saw is working the shape. It's coming up and down. We're going to jump ahead to the sweeping. Slow this down just a little bit. You can see how the blade's following the contour. That's what it should do for you. It should turn out a very nice finish. Maybe not crisp, sharp lines like you have on there, but the crisp, sharp lines were not defined on the surface either. So this will get you close. If you would like to develop it more than this, I'll have to play with it some more and see what we can do. But I think this will get you something close to the panel you're looking for.